So in this class we'll do this test-9C. Okay, we have already done A, B. Now we're in the third test, class 9, chapter 9, force and laws of motion. So let's start with question 3, page 134 on your textbook. Question number 3, page 134. Sorry, let me read the question for us. From a rifle of mass 4 kg, a bullet of 50 grams is fired with an initial velocity of 35 meters per second. Calculate the initial recoil velocity of the rifle. So here, as we read the question, we can write like this. Let us say MA is equal to 4 kg, represents the mass of the rifle, comma, MB is equal to 50 grams. Now we know we have to change this to kg by dividing by 1000, because SI unit of mass is not gram, kg. We've been doing this so many times, so I won't show these steps now. So 0, 0 cancel, then 2 places, or you can just do here 1, 2 and 3, so it will become 0.050. See here, 50 by 1000 means 3 places, 1, 2, 3, so one more 0 here. So we may as well avoid writing this, which is not necessary, so you can just write your kg. So you write here, okay, 0.05 equal to 0.05 kg, or nothing but RD, let's go slow, masses of the rifle, not rifle, yes, rifle, I think, yes, rifle, and bullet means it's bullet, respectively. And next, before fire, rifle is also stationary and bullet is also stationary. So let us say stationary means velocity is 0 meters per second, RD, velocities, okay, RD, velocities of the rifle and bullet respectively before firing. That means before fire, both are stationary. Then let us say here VA, now the is equal to question mark, because we're taking the rifle first, question mark, is the recoil velocity of the rifle after fire. So after fire, we know that every time a gunman fires, the bullet will move forward, but at the same time, due to Newton's third law of motion, equal and opposite direction will move backward in the form of the gun, which hits the shoulder of the gunman in the direction opposite to the bullet. That is called recoil velocity. I forgot to mention something which is not absolutely necessary. Now this is not a hard and fast rule, but I like to do like this because it makes it easy to understand. So let the bullet be moving from left side to right. This is assumption, so you just write here say. Say means we're assuming like that. Of course it can move from right to left also, but we're assuming from left to right because this helps us to understand. Okay, without writing like this also we can solve. Now VB is that of the bullet. It's given. The bullet moves with initial velocity of, after fire, 35 meters per second. So that is the movement of the velocity of the bullet after firing is they are saying initial, but that is the velocity of the bullet after fire. We know that from common sense also the bullet will move only after it's fired, so after fire. So we have UA, UB, VA, VB, MA, MB. So we can now use the law of conservation of momentum. So let us write down here. Total momentum before or after, whatever you like to write first, before fire is always equal to total momentum after fire. That is the law. But before we put the law, let us do separately. So that will be equal to, here, before fire is always mass of the first object into UA, initial, plus mass of the second object, bullet, into U. U involved is the before fire. So let us calculate that. As we go here, that will give you MA, here 4 kg. You can do slowly so we can understand it nicely. UA is here 0 into 0 meter per second plus MB, here 0.05 kg into 0 meter per second. As you can see here, UB is also 0 meter per second. So 0 into anything is everything will become 0. 0, so that is 0. Let us just put 0 kg meter per second, or just write 0 is also fine. Now similarly, the total momentum after firing the rifle. After firing the rifle will be MA into V. After firing is always V, before is U, right? Plus momentum formula is mass into velocity VB. So MA 4 kg into VA, we don't know yet, plus MB 0.05 kg, as you can see here, into VB is 35 meter per second. It's a matter of doing slowly. 4 kg into VA, this nothing can change. Multiply these two, then you are going to get here 35 multiplied to 0.05, 25, 17, 0, 0, no need to multiply. Now count the decimal place, 1, 2, so 1 and 2, so it will come between 1 and 7, 1.75 kg here in this one, meter per second. Let us put this one as equation number 2. So having done that, 2, so according to the law of conservation of momentum, we know that total momentum after fire or before, you can write first. After fire I'm writing first, because the quantity we want, recoil velocity, is on the after fire value here, VA is equal to, what is up to you, total momentum before fire. That is the law of conservation of momentum. The momentum cannot be lost or created also. Whatever momentum was there before fire and the total momentum of the gun and the bullet after fire is going to be totally the same, right? So therefore total momentum after fire is this one, 4 kg into VA plus 1.75 kg meter per second is equal to total momentum before fire this one before fire, and we finally found out to be 0. So put here 0, and I can write here, since using equations 1 and 2. Equations 1 and 2. So 2. Then you can continue. So here, as you continue, there will be equal to, that implies this one here containing the recoil velocity VA. Let us take that term on the same side, left side, without shifting. Put equal sign, and here's 0. So 0 can be forgotten. This one shifted to the right side, and plus 1.75 will become minus 1.75 kg meter per second. Getting right. Okay. Then recoil velocity, just put it alone here, VA, minus 1.75 kg meter per second divided by this 4 kg into means will become divided by coming to denominator. Kg cancelled. Then if you divide 1.75 by 4 and 1 is less than 4, so 0 point, then it will go after decimal 17. 4 4s are 16, 1 in hand, 5, 3s are 12. Then 3 remainder, then point means 0, 7s are 28, right? So that will be 2 in hand, 0, 4 5s are 20. So you're getting here minus 0.4375 meter per second is the recoil velocity with which the rifle will hit back the shoulder of the gunman. Now we can take approximation, because if this is too long, minus 0. Third place is more than 5, so this will become 4 4. Like this also we can do. And we can write here, which is clearly a minus number, so we write negative. This is significant, meaning this is minus plus is important. Therefore, okay, VA recoil velocity of the rifle is 0.44 meter per second, comma. Up to here the sign should be correct, but in your final answer you may not write if you don't want, or you may write also, up to you, because you're going to mention here even if you don't write, okay, in the direction, because it's minus, opposite to the bullet, meaning bullet was assumed to be moving from left to right, so that is from recoil velocity is from opposite, means from right to left. This makes us understand, that's why we're just using the term left to right. Otherwise also, if without using that also, answer is correct. Okay, so next, one more question. In this class we'll do this 3 and 4. The next class we'll do this, after which you can take this 9C test. Okay, so here 4, okay, textbook page 135. You'll find on page 135. Okay, so let us rub out this one first. Okay, so let us see there. Question number 4. This is page 135. Read the question for us. Two objects masses 100 and 200. Let moving along same line and same direction also. So let the two objects. This is not hard fast rule, but writing like this helps us to understand. That's why we're writing, let the two objects be moving from left to right. Okay, along the same line, same direction, the question is saying. Moving from left to right. So here, MA, mass of the first object, 100 gram. So 100 gram means divided by 1000 to change to kg, then 0.1 kg. Because the 3 zeros in the denominator, 1, 2, 3, go to the left of 1. These 2 zeros may not be written because the SI unit of mass is kg. That's why we're converting to this comma. MB is equal to 200 grams. So which is like dividing by 1000 again, 0.2 kg are the masses of the two objects respectively. Let's say then with velocities 2 and 1 meter. So first object is initial velocity was 2 meter per second. This is fine because this is an SI unit. Second object is moving with 1 meter per second are their velocities before collision, before they touch each other, before collision. Okay, so both are moving from left to right, plus plus therefore. Then V, after colliding, the first object moves 1.67, so 1.67 meter per second is the velocity of the first object after colliding or after collision. VB is obviously unknown. Velocity of the second object after collision. Okay, now determine the velocity of the second object. So this VB we have to find. Now we know this very clearly. The total momentum before collision is mass of first object into, always U is the before collision, V is after collision, mass into velocity is momentum, right? So mass of second object into UB. So that will be equal to mass of first object is 0.1 kg into UA is 2 meter per second. Second object is 0.2 kg I think into UB here is 1 meter per second. Just a matter of patience here. So they'll give you 1 into 2 is 2, just write that and count the decimal place here into, this is dot also, okay. Now here 1 decimal place, so it will move here and become 0.2 kg, then here meter per second, plus 1 into 0.2, 0.2 kg meter per second, and 0.2 plus 0.2 is common sense also, 0.4 kg meter per second. Let's put this one as equation 1. Similarly, total momentum after collision, let us say, it's always mass of first object, MA, into V now, VA plus mass of second object into VB. Then here, matter of doing carefully, that's all. Mass of first object is 0.1 kg into VA 1.67, so 1.67 meter per second plus MB 0.2 kg, so 0.2 kg into VB. We don't know yet, so just keep it like that. Go about it slowly, forget about the decimal. 1 into this one is 167, right like that, and count the decimal. Decimal places means on the right of the point, so 1 here on the right of the point, 2, so 2 plus 1, 3, so 1, 2 and 3, so it will be here 1, 2 and 3. 0.167 kg here meter per second plus 0.2 kg into VB. You can just keep it like that. This is equation number 2, let us say. And therefore, we know now, according to the law of conservation of momentum, according to the law of conservation of momentum, we have learned this in some classes ago. Momentum, we know this. Total momentum after collision is the one containing VB, so maybe we can write that first, up to us. Total momentum after collision is going to be equal to, according to the law, total momentum before collision. So we do that. Then next here, that implies total momentum after collision is here. So write that carefully, 0.167 kg meter per second plus 0.2 kg into VB is equal to total momentum before collision is this 0.4 kg meter per second. And we may as well rub out these portions because we have already written, and then you can write here, since using equations 1 and 2. Then next here, that implies the one containing the VB, the velocity of the second object after collision. That term 0.2 kg into VB, don't move that. Then put equal, and this one also don't move, 0.4 kg meter per second. And this no sign means plus, shift it that side, become minus 0.167 kg meter per second. So this has been shifted to the right side to make it minus. So a matter of subtracting 0.4 in this one. So plus 0.4 means I can just write like that. While subtracting, we have to make sure the decimal is on the same line, so 0.167, and wherever there is no number, you put zeros. Always put the bigger one up, so 0.4 is bigger than 0.1, that's why we put it up. Plus minus means subtract, so 10 minus 7, 3, 9 minus 6, 3, 3 minus 1, 2.0. Bigger number is 0.4, so this plus sign same will come here. So this 2 is sign of the bigger one, always comes in the result. So plus 0.233, when you do this 2, you need the same, see, kg meter per. That's why kg meter per second, that's why we could subtract, right? Then we write here kg meter per second. This side is 0.2 kg into VB. So that implies VB will be equal to 0.233, okay, 0.233, and kg meter per second divided by this shift this one, and it will go down to denominator 0.2 kg. So this kg cancel, and decimal place 1 is there in denominator, means it's better to remove. So 1 place means 10, 10 by 10 we put up and down. Then when you use this 0 here, decimal will move 1 place right, and if you use here, decimal will move 1 place right. So you're going to get here 2.33 divided by 1 place right on the right of 2 means 2. That's all. No more number there. At the back right side of 2, or right side of 2, yes. So this meter per second is the unit, which is correct unit of SI unit of velocity. Then if you divide this, you're going to get here 2 ones are 2, 2 ones are 2, 1 in n, 13, 2 6 are 12, 1 in n, 2 5 are 10 meter per second, which is clearly no sign means positive, or you can put plus also. Therefore, determine the velocity of second object. So velocity of the second object is 1.165 meter per second in the original direction, because it's plus, so it's still moving in the same direction, which means original direction, that is still from left to right. It was moving from left to right before collision. After collision also it's plus, so it will be moving from left to right. So that is the first two. We'll do the next two questions, 5 and 6, 136 page, next class. Okay.